Taking a look at the next transformation, note that I've got that x minus 3 inside of our logarithm, so that tells us that we're going to shift to the right 3. Recall, those are the opposite of what we expect. And we have that plus 1 on the outside, so this graph will shift up 1. So for logarithms, it's the left and right shift that determine the asymptote. So that will be the line that our graph does not cross right there. Right 3, that's an x equals 3 for our vertical asymptote. In order to get the rest of the points, I do recommend using a calculator because, again, it can be difficult to find those good whole number points. So we want log base 2. This is still from the previous example, so let's just change it up. We want minus 3. On the outside, we want a plus 1. Let's see what we get. We get a whole bunch of errors. No, we expected that. Keep in mind, we do not get a domain of all real numbers. We need to scroll down to find the ones that are actually allowed. Looks like I've got 3 good whole number points. Do I get one more? There we go. No, 11's not going to fit in our graph though. So we only get these 3 nice whole number points, 4, 1. We also get 5, 2. And last but not least, we get 7, 3. Again, there was one more that the calculator showed us, but 11 is too big for our little 8x8 graphs here. So remember, those 3 points are on the graph. We're not allowed to cross the asymptote. So when I start connecting the dots here, I want to hug that asymptote but not cross it, and then go through those 3 points. So unlike the exponential, the domain here is no longer all real numbers. It starts at 3 at that asymptote, and we'll get everything bigger than 3 all the way up to infinity. The range is where we get all real numbers for a long function. So enough of these quick transformations. Let's do an ugly one. Wrong button. There we go. So let's take a look at this ugly guy. So just like before, plus 3 on the inside, minus 4 on the outside. Hopefully we're pretty comfortable with those at this point. So we're going to have a left 3 and a down 4. We'll get those 2 transformations. So that left 3 will help us get our asymptote. And that's going to be at negative 3. Now we need to take a look at this negative 2 out front. Just like with the exponential, that negative sign tells us that we have a reflection. This graph isn't going to look exactly the way we expect it to. We are also going to get a stretch because of the 2. So this graph has a lot going on. Again, the calculator does have a good table feature to help us find some nice whole number points. So let's use it. Negative 2 times a log base 2. And then inside of that log, I want x plus 3. On the outside of the log, I want a minus 4. Let's see what our table gives us. Well, there's a nice whole number point, 1, negative 8. But that 1 point alone doesn't really help me figure out where this graph is. So let's scroll up because 5, negative 10 isn't going to fit. Negative 1, negative 6. And I also get negative 2, negative 4. So this graph is going to look a bit interesting. Remember, I'm not allowed to cross the asymptote. So the logarithm here is going to hug that asymptote and then run away briefly to get those 3 points. And that's it. Man, that looks weird compared to this one. But keep in mind, that's what a reflection does. Note that I used to have one that tapered off, kind of going up on the right-hand side. Now I've got one that's going down on the right-hand side. It used to go down on the left, and now it's going up on the left. So that's what a reflection does. That stretch is kind of interesting too. Now I've got a stretch of 2, so see I've got 2 in between those 2 points vertically and 2 in between those 2 points vertically. So that's where that stretch can be visualized on this graph as well. Again, the calculator really is kind of necessary to get those points unless you're really good at playing with the pattern. If you want to try one without a calculator, hey, raise your hand, I'll print you a random one, you can give it a go. Should be fun. Domain, just like the previous logarithms, is not all real numbers. It's going to start at -3, and we'll get everything else that is bigger than -3. So we're allowed to do -2, we're allowed to do -1, we're allowed to do 0, so on. The range is where we're going to get all real numbers. Note that it's upside down, but we still get everything. I have an arrow right here that's going to get all the positive numbers. I have an arrow going off this way that'll get all of our negative numbers. So the range is still all real numbers. We're good there. So at this point, we've got 3 transformation examples for logarithms, 3 transformation examples for exponentials. Now it's your turn to try a few. The attached practice, same thing. There'll be 3 of each, a couple simple ones, and then one with a reflection. If you're having trouble with your calculator, let me know. If you're trying to do a little bit of this by hand, I'm happy to help you there with the pattern as well. Let me know what you need. This is the last new section. So when you're done with the graphs, there'll be a spiral review. Remember, there is that test coming up. So if there's any support, anything at all that you need, now is the time to ask. I'll see you soon, and if you're feeling bored, come to Flex.